Okay, vectors that are perfectly horizontal or vertical are easy to deal with. What if they're not horizontal or vertical? What if they're angled at some angle? Well, we have to break them down into components. To do that, we're going to use trigonometry. In the first example, we're asked to find the x and y components of the vector 5 meters at 30 degrees east of north. The angle reference here is this angle. However, when we do trigonometry with our angles, we like to use angles that are with respect to the x-axis. Therefore, the angle really that we should use is this angle, which is 90 minus the 30 equals 60 degrees. Therefore, to find the horizontal component, remember we're going to use the cosine function. So the x component of this vector is 5 meters multiplied by the cosine of 60, which is 2.5 meters. And the y component of this vector, is 5 meters multiplied by the sine of 60, which is 4.3 meters. Let's do another example. Our second example here, we're asked to find the horizontal and vertical components of a 8 meters vector at 20 degrees south of west. Let's convert this angle into RCS coordinates. We know that RCS coordinates are Cartesian method. In the west degrees, it is 180 degrees. If it's an additional 20 degrees south of 180 degrees, therefore this angle is 200 degrees RCS. Another benefit of using the RCS or Cartesian method is that it automatically adjusts for positives and negatives. Remember, if a vector is pointing to the left or down, its horizontal and vertical components will be negative. In the x direction, again, the trigonometry function to use is cosine. So for this vector, it is 8 meters times the cosine of 200 degrees, which is negative 7.5 meters. And it's negative again because it is pointing to the left. In the y component, it is 8 meters times the sine of 200 degrees, and that is negative 2.8 meters.